Okay, this problem here looks like it's a quadratic, but it's actually not. And by quadratic, I mean it's an expression where we have x squared on both sides. But we're going to find out that it turns into a linear function. We'll see how. So the first thing we need to do is take and multiply these two things. All right, so when you want to multiply these, we have an acronym that we use in English anyway, FOIL, FOIL, and F stands for first. We take the first thing times the first thing and get x squared. And then we take the outside terms, that's the O, and we get negative 3x, x times negative 3. Then we take the inner terms, 9 times x is 9x. And then 9 times negative 3 is negative 27. Another way you may have seen this, some people do this with a set of boxes where they put the terms up here in such a way that you kind of fill in these boxes. You take x times x and you get x squared. X times negative 3 is negative 3x. 9 times x is 9x, and 9 times negative 3 is negative 27. And you get those four terms that way. Whichever way you like to do is totally fine by me. The ultimate result is not changed. We take and we add these two numbers because they are like terms, and we get x squared plus 6x minus 27. We've multiplied that through and distributed that. Now on the other side, it's maybe not as apparent what we need to do there, but that is the same as x plus 1 squared is x plus 1 times itself, which is another one of these products of two binomials. Now another thing you may know about this is there is a pattern to this. When you square a binomial, this same result happens every time. You take x and you square it. So take the first term and you square it, whatever it is. Then you take this term times this term, and you get 1 times x is 1x, and then you double that. 1x doubled is 2x, and then you square the last term, and you get 1. So that may be a shortcut you're familiar with, or maybe you've forgotten, but it's a time saver on a problem like this. Otherwise, we can come over here and multiply just as we did in the previous example. X times x is x squared. X times 1 is 1x, or just x. And see, the reason we take 1 times x and we double it is because I have taken 1 times x twice. X times 1 here and 1 times x here, and I get 2 x's. And then I get 1 times 1 is 1. And so these 2 x's, those are doubled, and so we get x squared plus 2x plus 1. That's a little bit of a short lesson on why this little shortcut works. So now I'll come over here and write the left-hand side equals, and then the right-hand side in our new expanded versions of them. And now the first thing we do is combine like terms, and so I'm going to move this x squared by subtracting it. And so I subtract it over to here, and a funny thing happens here is that this cancels on both sides. X squared minus x squared is gone. It's 0. X squared minus x squared is gone. And so I'm left with a linear thing. That's how this was an x squared problem to start with, but now it is actually a linear equation. And now we put our x's together on one side. When it becomes linear, that's what you do. You put your x's together on one side, and we get 4x minus 27 equals 1. And then we can add 27 to put our numbers together on the other side, and we get 4x equals 28. And then we divide by 4, and our final answer is x equals to 7. Now we can check that. That's the good thing about solving any equation. You can always check your answer. I'm going to do it in my head here. Let's see. If I put 7 in here, and 7 in here, and a 7 over here, let's see. So 7 plus 9 is 16. 7 minus 3 is 4. 16 times 4 is 64. And then over here on the other hand, I get 7 plus 1 squared is 8 squared is 64. So you see that it does work out. 16 times 4 is 64, and 8 squared is also 64. Just confirming that this is the correct answer.